Today the topic's polynomial division, but in order to do that we have to go way back, 4th and 5th grade, to talk about regular long division. So here's a typical division problem of the 4th grade, and we're trying to divide 22 into 352. So the first thing I was taught was how many times does 22 go into that 35, and that's a 1. And then we put our 22 down here, and we'd go ahead and subtract that, so I get a 13, and as long as 13 was less than 22, we knew we were good. And then we brought a 2 down here, and we said something to the effect of how many times does 22 go into 130? Okay, we can try 6. It gets me a 2, carry the 1, that gets me a 13, and hey, what do you know? We get 16 as an answer. Sometimes we would have well, let's just do a simple problem, if we will. Let's just do 20 or 207 divided by 10. Something simple as that. So we put a 2 here, and we get a 20. Bring that down, that's 0. So we have to bring down our 7. Does 10 go into 7? No, so we put a 0 there. And then we put a remainder of 7. Okay, now we can also write that as 20 and 7/10, if you think about it. So now we do this in terms of a polynomial, and the process is pretty much the same. We're going to use long division to start with, so we don't know how many times x minus 2 goes into all this, but what we do is we look at the first term. We look at the x and say how many times, or what do I multiply x by to get to x cubed, and that answer is x squared, and then I distribute that x squared to the x minus 2, thus getting x cubed minus 2x. Then, just like in 4th grade, I take and subtract all that stuff, and x cubed minus x cubed is gone away. Negative 5 minus a negative 2, that's a negative 3x squared, and I bring everything else down. Then I say x times what is negative 3x squared. I'm going to call that a negative 3x. And again, we take and distribute the negative 3x. I get negative 3x squared, positive 6x. And I'm going to subtract again. Negative 3x minus 3x squared minus 3x squared is 0. And 7x minus 6x is 1x minus 2. And we notice, hey, this goes in once. So in essence, since there was no remainder, this is actually a factor of the original polynomial. Again, it seems to be the same thing, but something is missing here. And when I say missing, it's an actual placeholder. There's no x squared term here. There's a 0x squared. So in order to do this, what I would do first is rewrite it, leave a space for my x squared term, and then continue writing the polynomial. Whoops, that's a radical. And then divide by the binomial again. So 2x times what is 4x cubed? That's a 2x squared. You know that's 4x cubed plus 2x squared. I'm going to subtract all that. That goes to 0. This is a negative 2x squared plus 5x plus 1. 2x times what is negative 2x squared? That is a negative x. So I get negative 2x squared minus x. Again, I'm going to subtract. These terms go to 0. 5x minus a negative x squared is 6x plus 1. Again, I look at this and I say, well, that's going to multiply by a 3, and thus 6x plus 3. Again, subtract. I end up with a negative 2. So my answer is x squared minus x plus 3. We can put remainder negative 2. However, it's more common to say 2x squared minus x plus 3 plus negative 2 over 2x plus 1. So this problem is just a little more confusing just due to the nature of multiple variables. But again, we'll go about it the same way. X times what is x cubed? That's just an x squared. Multiply, I get x cubed. Now I have 2a and x squared, which matches with this ax squared, so I'm going to pop that right underneath. It's just important that you make sure you line up your like terms, and we're going to subtract and get 2ax squared. So x times what is 2ax squared? That's 2ax. Multiply, get 2ax squared. Forgot to bring this down. Let's do that. And that's 4a squared x. So hey, all that goes. And I get 0 there, bring down the a squared, and that ends up being my remainder. So I have x squared plus 2ax plus a squared over x plus 2a. So now we talk about a special case when you have a divisor in x minus c form. Note the coefficient in front of the x must be a 1, and then this is a constant. All right, and we have that right here. We're asking to divide this term by x minus 2. Notice c in this case is equal to 2 because that c is always following a subtraction sign. So what we do is we put the 2 in a holding pattern, and then we list the coefficients of x in decreasing powers of x. So our first is 3. Now you need to notice, this is important, that we're missing our x to the 4th coefficient. So that has to be 0. We have a negative 7. And then we have a 1. And hey, again, we're missing a x to the 1st power. So we're missing that coefficient. And then a negative 7. So we have 2 placeholders in this case. Our next step is going to be a repeated process. Well, actually not. The first thing we do is we're going to bring down the first term, and then we will do a repeated process. That process is on the diagonal. We will multiply this holding pattern number, if you will, by the term down under this line we drew. So that gets me a 6. And then we're going to take and add vertically. So I get a 6 here. Then again, I'm going to, on the diagonal, multiply, get a 12, add 5, 10, add 11, 22, add 22, 44, add 37. So what really did that get us? Well, it actually got us the answer for the division in that this term will always be your remainder. And then the rest of these terms are the answer in terms of descending powers of x. So what we're going to do is we're going to back up from our constant to our x to our first, x to the second, x to the third, and x to the fourth. So our answer in this case is going to be 3x to the fourth plus 6x cubed plus 5x squared plus 11x plus 22 plus 37 over x minus 2, which is always going to go a heck of a lot quicker than doing long division on something like that. Now, there's this concept called a remainder theorem that says if you divide a polynomial by x minus c, then the remainder will always be f of c. In other words, if you took that c term, plugged it into the function, and came out with an answer, you would get the remainder. So in this particular problem, if I had 2x to the 100th plus x to the 39th plus 7, and I wanted to know the remainder if it were divided by x plus 1, Well, is that an x minus c term? First of all, yes it is, because that's x minus a -1. So c in this case equals -1. Now think about how ugly it would be to list all the missing coefficients and then do synthetic division on this. It would take forever. All right, so if we just want the remainder, if that's all we're interested in, all we have to do is take f of c, which in this case is -1, and plug that in. So I have -1 to the 100th plus -1 to the 39th plus 7. This gets me a +1 times 2 is 2. This gets me a -1. This gets me a 7. And I'm left with a remainder of 8. Again, only works when you have an x minus c form. Okay, now again, they're asking us in this problem, they tell us that x plus 2 is a factor, which means that it should go into this polynomial evenly or with a remainder of 0, and we want to find the remaining factors. Well, let's take a look at what happens first. This is an x minus c form, so this is x minus a -2. So c is -2. Pop my c term here. I'll list the coefficients in descending powers of x. In this case, we have no missing powers of x, so there are no placeholders. We bring down the 1, and then we diagonally multiply, get a -2, which gets me a -4 because I'm adding, get a +8, which is a 3, and then get a -6, which is totally expected because I should get a remainder of 0, which I did. Now notice my remaining term is x squared minus 4x plus 3. And the question asked me to find my remaining factors. So hopefully this factors, and it does. I get x minus 3 and x minus 1, and those are my remaining factors. That's all we have for today. See you next time.